All right, for this video, we're going to go over 2D. It's at the bottom of the screen. Just trying to get this started here. All right, so 2D, we have an equation which is 6x to the 1/2 power minus 11x to the 1/4 power minus 35 equals 0. So this is not a polynomial. It's not a quadratic, but we can solve it like a quadratic because we have two, we have one variable, x, being raised to two different powers. And the ratio of those powers is 2 to 1. 1/2 to 1/4 is 2 to 1. So when that happens, you could do substitution and let the variable raised to the smaller exponent equal something like a. And then when you square both sides, that means that becomes x to the 2/4, so x to the 1/2 is equal to a squared. So we can substitute in a squared for x to the 1/2, and we can substitute in a for x to the 1/4. So now we're going to solve this like a quadratic. And the way we would solve this quadratic is by factoring. Now, I don't know if this factors, but we have to find, to see if it factors, we have to find two numbers that multiply to AC. So that would be 6 times negative 35, whatever that is. All right, and adds to B, and adds to negative 11. So 6 times negative 35, let's see what that is real quick. Probably should be able to do that, but I can't. Is 6 times 35 is 210. So we got negative 210, which is nice because I could see which numbers we need to factor right away. All right, if I need to find two numbers that multiply to negative 210 and add to negative 11, I could see that negative 210 is equal to negative 21 times 10. So that has a sum of negative 11 and a product of negative 210, which means we could factor this. So we're going to break up this middle term as negative 21a plus 11a, and then rewrite the other parts exactly how it looks. So 6a squared minus 21a plus 11a minus 35 equals 0. Now I'm going to factor by grouping. So I'm going to pull out a 3a in the first two terms. So I'm left with 2a minus 7. All right, because that's a common factor between these two terms. 6a, good. And then the other two numbers don't have any common factors. Oh, that's because I wrote this wrong. This should be a 10. Sorry, my bad. So 10 and 35 have a common factor of 5. So I could pull out a 5, and I'm left with 2a minus 7 equals 0. And then pull out a 2a minus 7 times 3a plus 5. And now I have this factored. So I could set each factor equal to 0. And I get a is equal to 7 over 2. And a is equal to negative 5 over 3. All right, so those are my two values for a. But I'm not looking for a. I'm looking for x. And I know x to the 1/4 is equal to a. All right, so now I'm going to take what I have in blue, erase everything else, and rewrite those things. So 7 over 2 and negative 3/5, sorry, negative 5/3 is what we got for a. And now I got to see what x is, knowing that x to the 1/4 is equal to a. So I have a is equal to 7 over 2, and a is equal to, I think it was negative 5/3. All right, I hope that was what it was. Wait, I could check. Yep, negative 5/3. Okay, and I know that x to the 1/4 is equal to a, so I'm going to plug that in. And now I'm going to solve these equations. So the way I would solve x to the 1/4 is equal to 7 over 2 is to raise both sides to the 4th power to get an exponent of 1 by my x. So I get x to the first is equal to 7 over 2 to the 4th power, which 7 to the 4th, I don't know off the top of my head. I could type that in the calculator. I get 2,401 over 16. All right, and then if I do x to the 1/4 is equal to negative 5/3, all right, and I raise negative 5/3 to the 4th power. Negative 5 to the 4th power is negative 625, and 3 to the 4th power is 81. So those are my two solutions. Now they might be extraneous, so you would have to plug them in and see if they worked. Or if you have a CAS calculator, just solve that with a CAS and see if you get those solutions. But that's how you do it.